so what I want to start with is we're going to add something at the top up here. Maybe. Okay, we're going to add a question up here, and we're going to answer it up there as well. Okay, so mine's like underneath 4.3 notes on top of that line. Okay, so our question is, why do atoms emit radiation? Why do atoms emit radiation? Okay, so go ahead and write that question for me. Why do atoms emit radiation? Does anybody know the answer to that? It's okay if you don't. Okay? So we get radiation from atoms because they have their nucleus is unstable. All right? So that's going to be our answer. They have an unstable nucleus. All right, so that's why atoms give off radiation in the first place. Okay, their nucleus is really unstable, kind of like if you're about to have a mental breakdown, right? Okay, anything can just push you over the edge at any given point. That's how their nuclei are, and they're really unstable, so they emit radiation to become stable. Okay, they're trying to do everything they can to get back to stability, and it comes off in the form of radiation. Okay, so there's going to be 3 types of radiation that we talk about today: alpha, beta, and gamma. Okay, driving question today: what are the types of radioactive decay? All right, that's what we're going to find out. What are the types of radioactive decay? Okay, so what we're going to talk about first is something called transmutations. All right, there are 2 types of radioactive decay in which the atom changes from one type of element into another. This is called a transmutation. All right, so a type of decay that changes one element into a whole new different element. Okay, and it's called transmutation. All right, mutation, I feel like is the easiest part to remember because if something's mutated, it changes. Okay, so that's how I remember what transmutation means. It's going to change elements. All right, those 2 types of decay are going to be alpha and beta decay. All right, so let's talk about those 2 first. I'm going to scroll up a little bit and erase so that I can go ahead and fill all this information in. All right, so the 2 types that cause transmutation, they cause elements to change. Let's talk about alpha first. Alpha decay, symbolized by the Greek letter alpha, which is that thing right there. Okay, so anytime that you see this symbol, it's kind of just a weird looking A. It is a symbol for alpha decay. All right, let's talk about alpha decay. So in alpha decay, the unstable nucleus is going to emit a helium nucleus. Okay, so that's what you need to remember about alpha decay is that it resembles a helium nucleus. It's going to have 2 protons and 2 neutrons. So sometimes whenever it's written in a chemical equation, okay, instead of using this symbol, they're going to use this helium symbol, all right? So this thing and this thing are equal, all right? Those are the same thing. The alpha and the helium are going to be the same thing when you see it in a chemical equation. Alpha particles are relatively slow and large. Okay, so this type of radiation can't do a lot of damage. All right, they're really slow. They're really large compared to other types of radiation, so they can't penetrate that far. Okay, in fact, It can be shielded or stopped by a single piece of paper. Okay, something that can be stopped by a piece of paper is not very strong. Okay, it can't cause that much damage. If a piece of paper can stop it, then we shouldn't be too worried about it. Okay, alpha decay is not really one that us humans are worried about. All right, the other type of transmutation is going to be called a beta decay, symbolized by the Greek letter beta, which is like a capital B with a little tail. So in beta decay, a neutron is going to turn into a proton. A neutron becomes a proton. And a fast electron gets emitted. Okay? That is a key point there. Alright? A fast electron gets emitted. So, an electron is the same as this beta symbol. Okay, that E with a -1, because that's the charge of an electron. Alright? This tells you automatically that it's going to be beta decay. If you see that lowercase e with a -1, you know that you're looking at some type of beta decay. Okay? So a neutron is going to turn into a proton. Alright, that's the transmutation. And then a fast electron gets emitted. So it's going to shoot out an electron. Beta is a little bit stronger than alpha decay. So beta can penetrate through paper, but it's going to get stopped by aluminum foil. Okay, so those are types of transmutations. Alpha decay gets stopped by paper. Beta decay is going to get stopped by aluminum foil. When you get that down, go ahead and turn the page for me. Oh, I'm sorry. I did not even obviously pay attention to that. Okay, remember electrons have no mass and a charge of -1. Thank you for catching that. Now you can turn the page. So we're going to go more into detail about these two types of decay, alpha and beta decay, and then we'll talk about our third one at the end, which is gamma. All right, so topic question for alpha. How does a radioactive atom change during alpha decay? All right, so the parent isotope, so all of that means is the one that you start with, so the starting isotope, spits out a helium nucleus and becomes a daughter isotope. So this is going to be what you end up with. All right, so this is an example of what a chemical equation would look like if it underwent alpha decay. Okay, so this is my parent right here. My PO is going to be, this is my parent isotope. So this is the one that I start with. Okay, it's really, really unstable. So it's going to try to gain stability by going through alpha decay. Okay, remember alpha is a type of transmutation, so it's going to change this PO into something else. All right, alpha decay happens, it's going to shoot out a helium nucleus. We talked about that. Okay, helium is 4, 2. And now this is where the change happens. I don't have PO anymore. Now I have PB. So this is my daughter isotope. Okay, it got changed. A transmutation took place. You are not going to have to worry about this math, so we're just going to go ahead and fill these in. Okay, but if you look at it, 214 plus 4 equals 218. Okay, 82 plus 2 equals 84. All right, so that's an example of alpha decay. Let's talk about what happened. All right, so I started with polonium 218. It's going to lose 2 protons to become a lead nucleus. Okay, so this is my lead nucleus. Pb is the symbol for lead. It also lost 2 neutrons, so its mass was decreased by 4. Okay, all that I need you to be able to recognize is that if you see this, you know that it was alpha decay. Okay, this isn't always in that arrow. All right, so if you see that a helium was shot out, then you know that it's alpha decay. Okay, if you see that this is not the same as this, you know that a transmutation happened. Okay, something got changed. All right, so we are not going to worry about this. Okay, I'm not going to expect you guys to do that part, so you can mark it out. And then, wow, it's like magic. Okay, that element gets changed like magic, but it's actually due to radiation. Okay, so remember, transmutation, big word, something got changed. In alpha decay, this polonium atom got changed by releasing a helium nucleus, changing it into lead. All right, let's see how beta decay changes things. Beta decay. How does a radioactive atom change during beta decay? That's what we're going to find out next. All right, so we talked about this on the first page, but in beta decay, a neutron is going to become a proton. A neutron in the parent isotope becomes a proton and ejects a what? What is emitted? A fast electron, yep. Neutron becomes a proton and ejects an electron. All right, so let's talk about what's going to happen. Okay, remember alpha and beta are part of transmutation. So I'm going to start with something and then end with something different. Okay, in alpha and beta, something has to change. All right, how this gets changes is it's going to shoot out an electron, right? So electron has a charge of -1. So I'm going to go from lead to bismuth, all right? And we're going to put 214 up here and then an 83. Okay, once again, what I need you guys to get out of this is that anytime that you see this E, you know that it is going to be beta decay. All right, that's what I need you guys to know is that that little E means that some sort of beta decay is happening. All right, so let's put what happened into words. Lead 214 lost a neutron, but gained a proton. Okay, because that's what happens in beta decay. Neutron becomes a proton. And then that led it to become a bismuth atom. All right, let's think about this question here. So the mass is the same. So I went from 214 with lead to 214 with bismuth, all right? So why are the mass of the parent and daughter isotopes equal? Does anybody know? Think about what makes up the mass of an atom, neutrons and protons. The only thing that changed was this neutron became a proton, right? Okay, so if I lose a neutron but gain a proton, my mass isn't going to change because they're both included in my mass number. All right? So we're going to write our answer in this little cloud here. Protons and neutrons. Both have a mass of 1. So if I lose a neutron but gain a proton, nothing is going to change. And then you don't have to worry about this. Go ahead and mark through that bottom part. Alright, so transmutations, alpha and beta decay, they're going to change your parent isotope. Alright? Parent isotope is going to change. Okay, let's talk about our third type of radiation. We haven't said anything about it yet. It is not part of transmutation, so it is not going to necessarily change anything. You're not going to get a different daughter isotope than you have a parent isotope. Alright, but this is the most dangerous one. Okay, out of our 3 types of radiation, this one is the most dangerous. This is the one that changed Bruce Banner into Hulk, right? Okay, so this is super, super dangerous. What is the third type of radiation associated with radioactive decay is our question. What is the third type of radiation associated with radioactive decay? And that is going to be gamma rays. Symbolized by the Greek letter gamma. So, a Y looking thing.
Short Y.
Yep. Okay, with gamma, you're probably also going to have either an alpha decay or a beta decay. Okay, so alpha happens, beta happens, and gamma is kind of like a result of it. Alright, so right here we're going to say that it accompanies both alpha and beta decay. So you won't find gamma by itself. Normally it's paired with alpha decay or beta decay. Alright, so what is a gamma ray? A gamma ray is a high frequency wave It's a high frequency electromagnetic radiation which travels at the speed of light. So super fast. High frequency electromagnetic radiation which travels at the speed of light. Okay, so alpha can be blocked by what type of material? Paper. Beta can be blocked by aluminum foil. Gamma ray can only be shielded by a big, thick piece of lead. Okay, so it's going to shoot through paper. It's going to shoot through aluminum foil. It can be stopped by lead. That's 1.5 feet thick. Or by concrete. That's 6.5 feet thick. Okay, so it takes a lot to stop these gamma waves. All right, the rays of gamma. A little fact, nuclear fallout shelters were meant to protect people from the threat of gamma radiation after a nuclear explosion. Okay, so the thought process there is if our shelters, say after Chernobyl happened, okay, there's usually nuclear fallout shelters where people can go to get protected. If that nuclear fallout shelter can protect against gamma radiation, then it's already protecting against alpha and beta because they're not as strong. All right, so those shelters want to be able to protect people from gamma radiation because that's the strongest type of radiation. Okay, so those are the 3 types of decay, alpha, beta, gamma. Remember, alpha and beta are going to change that starting atom, okay? And then gamma is going to follow either alpha or beta decay. All right? What I need you to do now is go on the Canvas, and there's a 4.3 note check. All right? Use your notes to help you. Once you get that done, that's all that we have for today. Okay?